right, this is pretty short today. Don't have much to go over. We just have one lesson due this week, and then we're done with all the lessons. So let me put up on your screen. Let's look at what is due in Algebra 2 this week. So if I go to Algebra 2, go to the grade screen, make sure I'm in syllabus order. All right, we see what's due this Sunday. It's one assignment, functions of all types. Functions of all types. Oops, I didn't mean to click on that. Functions of all types is the only thing due. And then all we have left is the test, trigonometry test, and then our semester final coming up here at the end of the month. So this week is functions of all types. So let's look at that together. I'll just change my screen. All right, so functions of all types is simply this. We're taking all the functions you've learned up to this point and having you compare them to see what you know, just making sure that you can compare one function to another function. So I'm just looking at the actual assignment. This is actually for our assignment for this week. I'm going to look at the first couple of problems with you. And so you should be able to certainly get these right. Compare the functions below. It says, which function has the greatest y-intercept? Okay, that's what we're comparing. When you compare functions, you got to figure out what are you comparing, because there's several things you can compare, right? The greatest y-intercept. Well, the first thing we have is the linear equation here, f of x. And with the linear equation, mx plus b, the b is your y-intercept. So you know that is going to cross the y-axis at -5. We have a graph for g of x. All we have to do is look and see where does it cross the y-axis, and it's at -3. So right now, g of x has a greater y-intercept because -3 is larger than -5. All that's left now is this over here. H of x equals 2 cosine 2x minus pi plus 4. Okay, so right off you're thinking, okay, I'm not really sure how to do that. Well, if it was just cosine of x, we know it looks similar to this. This is like a sine graph. You know, cosine looks a lot like it, except the cosine generally crosses at 1. The sine generally crosses at 0 a lot of times. This is probably either a sine or a cosine. It's just either shifted somehow. Let's look and see what happens here. If we put a 2 right here, all that does is squeeze it closer together. It doesn't raise the wires, but squeeze it closer together. This out here will double the height, the 2 out front. So now instead of this just going from 1 to -1, it's going to go from 2 to -2. This minus pi inside here is going to shift it. So now it's not going to be crossing at the 1 or the 2 because it's shifted over. So it's probably going to be on the negative side. And then plus 4 just simply raises it 4 on the y-axis. So let's look at this on a graph real quick. I will change over. Y equals, let's start with just the cosine x. There's the cosine x, as I talked about. It just goes from 1 to -1. And we put this 2 inside here with the x, it just squeezes it closer together. Squeeze it close together. But when we do that minus pi, see, that's where it moved it to the left. It subtracted a distance of pi. So now it is crossing at -1 is where our y-intercept is. But when we put the 2 out in front of it, it doubles the height. And then the plus 4 moves its way up here. So it crosses the y at 2. So crossing the 2 definitely going to make this larger. This is a -5. This is a -3. This is a 2. So h of x is going to have the greatest y-intercept. Greatest y-intercept right there. Let me look at another problem since I got you here. Compare the following functions. Now this wants to know what is the correct order from least to greatest. Let me highlight that. According to the average rate of change, which is also known as the slope, right? The average rate of change. From 0 to 4, when x equals 0 to x equals 4. Okay, so let's look at these 3 functions they have. They have f of x, g of x, and h of x. When f of x is 0, the function equals 0. Right? When it's 4, it equals 64. So this one goes up 64 over a span of 4. So that's an average slope of 16 between those 2 points. 64 divided by 4, 16. This one, we have a graph at 0, it's -1, and at 4, it's -3. It only goes up, well, it goes down actually, it goes down 2, it's right there, over a span of 4. So it's got a -1/2 slope. So it's right now, this is the least, and this is the greatest. Let's check one over here. This one, if we need to go from 0 to 4, we just substitute 0 in for the x, which I've done right here on the side. 0 plus 4 squared plus 2. So 0 plus 4 is 4. 4 squared is 16 plus 2. So this starts at 18. Right? This is the starting point when x equals 0. And when x equals 4, 4 plus 4 is 8. So 8 squared plus 2, 64 plus 2. This goes up to 66 when x equals 4. So 66 minus 18 is 48. 48, and when you divide that by 4, you get an average slope of 12. So from least to greatest, we got g of x first. G of x first. Then we have h of x because it's 12, and finally f of x. So we're looking at this one. All right, so there's only, what, 1, 2, 3. This is comparing the functions below, which has the most x-intercepts. And this is like a sine graph again, or cosine, one or the other. But it says only in this interval, only from 0 to 2 pi. So this is limiting. Here's 2 pi right here. So only from here to here, how many x-intercepts it had. This is which has the maximum y value. So what's the highest point, which would be for this graph, the highest y value is 3. Comparing it to this table and this equation over here. Compare these functions, which has the smallest minimum y value. And you have 2 different equations and a table. But you can always put that on a graph, see what it does. And that's it, five problems this week. So we have these 5 problems, and then next week we'll start testing, which is all we'll do the rest of the month, right? We'll have our unit test, and then we'll have our semester final. I will have information on you can exempt, but I will have the requirements for that on next week's meeting. I'll start telling you what's required to be able to exempt. I know in the school building, no more than 4 absences or tardies. All assignments have to be turned in, and your grade has to be a 75%. Now, for virtual school, it could be different. It's up to our principal, so he'll be sharing that with us this week, what our exemption rules are, but could be very similar to what's in the school. So make sure you get everything turned in and get this turned in this week, and then be ready for testing. So that's all I have for you. Everybody have a great week. I will see you next time.
Let's get out of here. Word to your multiples. Math